CFA Level 1 Practice Questions. Learning Module, Introduction to Big Data Techniques. Topic: How is Fintech used in quantitative investment analysis? The veracity dimension of big data is most closely associated with A. The accuracy and trustworthiness of the data. B. The vast scale of data generated from sensors. C. The range of structured and unstructured formats. An investment firm is developing a model to predict retail sales by analyzing satellite images of parking lot traffic at major shopping centers. The firm's data scientists are using a machine learning technique that involves training an algorithm on a large historical dataset of labeled images, where each image is tagged with the corresponding known sales figure. The primary source of this alternative dataset is most likely classified as data generated by A. Individuals, B. Business processes, C. Sensors. Which of the following is most consistent with the concept of Fintech? A mobile application that allows peer-to-peer lending outside of traditional banking channels. B. A statistical test comparing correlations of portfolio returns. C. A government report on fiscal and monetary policy. Which of the following best captures the defining features of big data in the context of financial services? A. The exclusive use of structured financial data stored in traditional databases. B. The analysis of small, homogeneous datasets to identify simple trends. C. The ability to process and derive insights from vast, diverse, and rapidly generated datasets. Which of the following best illustrates the use of robo-advisers in investment management? A. Automating portfolio allocation for retail investors using algorithms based on risk tolerance questionnaires. B. Detecting sentiment shifts in market commentary by applying natural language processing. C. Executing high-frequency trades across multiple exchanges to exploit short-lived price discrepancies. Veracity is all about how trustworthy and dependable the data comes from. It's more about the quality of the information than just how much there is. Veracity clarifies that volume is all about the size or number of data points, while variety is about the different ways data is organized, like structured, semi-structured, or unstructured data. Satellites are explicitly categorized as sensors. They are defined as machine-driven data collection tools that capture observational data, such as traffic patterns in parking lots, to provide investment intelligence. Individuals and business processes are excluded because they require human activity, social media, clicks, or corporate documentation, transaction records. Satellite images are neither human-generated nor internal corporate outputs. Sensors are device-generated tools that measure the physical world. This contrasts with individuals who generate data through online behavior and business processes, which are structured organizational flows. Fintech is technology-driven innovation in the design and delivery of financial services. A mobile app for lending is a new system that challenges traditional business models of incumbent providers like banks. Statistical tests and government reports are often grouped with traditional quantitative methods or data sources. They're seen as analytical tools or inputs, not the innovative delivery systems that Fintech is known for. Fintech is all about using technology to make financial services better, while traditional methods rely on well-established mathematical techniques. Fintech is like shaking things up in how we manage investments and provide services. Big data features are all about the three verses: volume, a huge amount; velocity, they come in fast in real time; and variety, they come in different formats like structured, semi-structured, and unstructured. Choice C is a great match for these features. Choice A is incorrect because it describes traditional data, which is limited to structured formats like SQL tables. Choice B is the opposite of big data. which is characterized by massive, complex, and heterogeneous datasets, rather than small, simple ones. Big data represents a shift from limited, homogeneous data to massive, diverse, and often real-time information streams that require advanced analytical tools, like machine learning, to process effectively. Robo-advisers are like the new superheroes of investment advice and financial planning. They use smart algorithms to handle the boring, repetitive stuff, so you can focus on making smart decisions based on things like how much risk you're comfortable with. This makes financial services easier to get to for everyone. Natural language processing, NLP, is a way to analyze text and understand how people speak. It helps us figure out what's being said or how people feel about things, like in market reports. This is a bit different from how we manage our investments. High-frequency trading, HFT, uses super-fast systems and special programming, like C++, to crunch numbers and act quickly. It's a fintech tool, but its main aim is to catch little price changes in the short term, not to handle big retail investments. Topic: Advanced analytical tools, artificial intelligence, and machine learning. A limitation of machine learning in investment analysis is that models are fully transparent, making their decision process easy to interpret. Algorithms may adapt too closely to historical data and fail to generalize. Once trained, models automatically adjust to new data without human oversight. When training a machine learning model, analysts must be cautious of overfitting. Which of the following best describes the primary risk associated with overfitting? The model becomes too simple and fails to capture meaningful patterns in the data. The model performs well on training data, but poorly on new, unseen data due to learning noise. The model requires excessive computational resources for training. Clustering customer transaction data into groups based on spending behavior without pre-labeled categories is an example of supervised learning, unsupervised learning, deep learning. Overfitting occurs when a model learns historical data, including noise, too precisely. This makes the model too complex and prevents it from accurately predicting outcomes on new, different datasets. Machine learning models are often described as black boxes because their internal logic is opaque and difficult to explain, which is the opposite of being transparent. Furthermore, ML is not fully autonomous. It still requires human judgment to clean data, address biases, and select appropriate analytical techniques. While traditional models are often interpretable, ML models can fail to generalize if they are overtrained, meaning they are excellent at matching the past, but poor at forecasting the future. Overfitting can happen when a model gets too good at memorizing the training data, so it starts to see random noise as real information. This makes it super accurate on the training set, but it struggles to understand or predict things on new, unseen data. Overfitting happens when a model learns the training data too well, even the noise, and it doesn't generalize well to new data. Underfitting, on the other hand, is when a model is too simple and doesn't capture the real patterns in the data. Overfitting is more about how well the model predicts, while computational cost is just about how much resources it uses. Unsupervised learning is all about letting the computer explore data without any labels. It's like teaching the computer to find patterns and structures, like spotting groups of customers with similar spending habits. Just so you know, supervised learning needs training data with labels. That is, both the input and output are clearly marked, so the algorithm can figure out how they relate. Since the question mentions no pre-labeled categories, this method won't work for you. Deep learning is all about using neural networks with lots of hidden layers to tackle complex, nonlinear problems. The question is more about a general learning approach, like clustering without labels, than a particular network design. Topic: Tackling big data with data science. Which of the following is an example of applying text analytics in investment management? A screening analyst reports for changes in tone that may signal revisions in forecasts. B. Estimating portfolio beta using historical return covariance. C. Monitoring liquidity spreads across different bond maturities. Text analytics, especially when using natural language processing, NLP, is great at understanding data that doesn't have a clear structure, like analyst reports. It helps spot when people's feelings change or their tone shifts, which can give us clues about what might happen next, like when a forecast needs to be updated. These kinds of insights are something that regular math models just can't do. Options B and C use organized numerical data like prices, returns, and spreads, which are typically used in quantitative techniques. On the other hand, text analytics is all about digging out the meaning and patterns in human language.